usually somewhere around an hour's time. I think this should
Okay, we'll make a start then. Good morning. Welcome to the fifth session of the mobile app development. In response to quite a few comments or people have been emailing me, I thought I would bring forward the discussion on the assignment fee. A lot of people are wanting to get underway with it, and you've actually done enough after the lab this week. I know some people still got to do their labs this week. After this week, we'll have enough to actually do the assignment with them. You've already done enough to get the first question out of the way. I'm just going to have an overview of what the assignment's about, what sort of stuff you'll need to be producing, and how fast to lay out the overall strategy of approaching it. The scheduled lecture that we're going to have today, I've just pushed the other things back a week to sort of work with. So the labs this week will be on the Android connection to your fidgets. And next week I'm going to have a bit of a catch-up lab, let people sort of get together either labs you haven't created or finished, or similar for this lab 5 on connection to fidgets. Also, you may want to sort of ask me any questions in the labs next week about assignments and things. But the labs this week are on this Android connection to fidgets. Okay, one thing to keep your eye on, and I sort of get a bit of feedback from some people saying, oh, I never read my emails, things, you know, or I only read them every 4 weeks or something like that. There's a lot of stuff being sent out over the email to help you with the assignment. It goes on to, I've generally put it on the forum, and all those forum messages automatically get emailed out to you. So you do really need to keep an eye on it. I met one guy the other day who said he hadn't read his emails since the start of term. So you know, you can end up missing out on some things. But you'll see on Moodle that you'll have that sort of forums link to get to the pages. And incidentally, again, something that people have been asking me about is, can I come and see you? I want to come and talk about the assignment, I want to come and talk about some labs. I'm very willing to talk to people, to arrange an appointment, but it is under the assumption that you've at least tried some of this stuff. Rather than coming to see me and basically wanted a repeat of one of the lecture talks or one of the labs. It doesn't scale up very well, that sort of thing. There's 180 odd people in this thing, and if 180 people came along to me and said, I want an individual discussion of what you said in the lecture or the lab, please can you give it me? It doesn't, as I say, sort of scale. But that availability there, if you just follow the link, that gives you my hour by hour availabilities through the week. And if you can just sort of follow the link through to the timetable, you'll see the sort of slots, and you can perhaps sort of suggest a couple to meet in. Bearing in mind, as I say, that hopefully you'll have done some of the work already on the labs, and you come to me, you know, a bit prepared for that. So today, just to have a look at some of the things to do with the assignment. The announcements page, this forum, does have these links to common questions. Somebody posed a good question last night about can I connect to MySQL to my Android code. I'll talk a bit more about that later on. But if I get a good question off people, I'll often just share it with everybody there. Or bits about for the assignment, how you definitely need a client and server and things. The diagram that I'm about to show you, there you'll see important about getting started on your assignment. Part of that does include the actual diagram that I'm about to talk over. So if you want copies of what I'm sort of doing today, the ways of getting to that the actual diagrams there, but also, as always, these big lecture theatres are recording the lectures, so anything that's on that screen will be available just to sort of review yourself as we go through. Okay, so just having a quick look at what this assignment looks like, what it's about. Basically going to be covering, there's three main tasks in this, and the first two are the coding ones that cover what you've really done in the labs, that show what you're talking about from what we've done in the labs. So tasks 1 and 2 are about recording sensor data and actuating it from your widgets. Task 2, they're linking that into the phone application. Now, 50 marks there and sort of 30 marks for this sort of design, that really reflects the relative emphasis with the time that you've got in the different sessions that we do together. Like you've got 2 hours of lab, 1 hour of theory, and there the bulk of the marks are for the practical implementation. So you'll find tasks 1 and 2 covered in the labs, and task 3 coming out of what we're doing in these lecture sessions for it. It does entail talking a lot about nodes and things, so there's some assumptions about the terminology that we're using, that you become aware of what some of these things are, but what is a node and the like, and what is a client and server. And that's a couple of the things that I want to talk about today. To many people, what a client and server is fairly obvious, but again, perhaps sort of judging by some of the questions and feedback and people starting their assignment, there still is a bit of confusion over that. But basically, you're to take, in that sort of task 1, taking an RFID card and have the ability to open a lock with it. Now, we did that back in week 1. With the start point to that. You read an RFID card and you turned the motor, and one of the exercises was to do that in one single program. The change here is we're actually going to separate these and make them 2 programs. Again, sort of I'll explain reasons for that just in a moment. So you can't just use the exact solution there for it. You need to get the 2 processes talking to each other on separate devices. That will involve either communicating to a database, where perhaps the RFID card stores its value in the database, and the lock checks the database periodically to see whether or not that RFID card has been updated or some new value appears. More realistically, we'll do it with MQTT, so that the RFID card will broadcast the message out, and the locking mechanism will pick that message up. And I'll just do a little diagram for that in a moment. There'll also be the requirement to store information about the success or non-success of these attempts to open the door lock. So whatever sort of happens, you really should sort of record it. Say that X, this person X managed to open the door at this time, or this particular card tried to open the door, wasn't valid. So there's going to be a bit of validation in here somewhere to decide which cards are okay. Now, all of that has been covered somewhere in the labs to work with, and you can make good use of those labs. There's no restriction on what you're using from the labs. You feel free to use that sort of code to work with. And that final sort of sentence in the first sort of task 1, ideally we should be sending this data in JSON format. That really covers the sorts of things that I think we did really in the first sort of 3 labs for it. This bit's about the mobile phone integration. That just allows you a separate way to operate this lock. Rather than using it with an RFID card, if you've got the phone app for it, and it's sort of suitably verified with your credentials on it, you can click the button to open the door, or get information on the status of the door lock, saying the door is currently open, closed, whichever. And actually the 30 marks given there does rely on you having done that first part to it. So that's the sort of practical part to it. and I'll spend most of today talking about that, but the third part, this task 3, is more based on what we're doing in the lecture sessions about designing some sort of sensor network, where you'll decide where things like controller nodes are, where the actual nodes with these sensors attached to it and motors are. And we've got this scenario about having a smart valve system, where these valves will perhaps be attached to, say, a garden sprinkler, and you might have several of these dotted around a park area or a large lawn or something like that. And you control that individual device. Well, the individual device will have its own node, so it'll have a processor on, and then you'll have a centralised hub to work with it. Now, this particular system will be very similar to what you have in, say, central heating control systems, these smart ones. It's almost exactly the same approach. If instead of there we think that's like a solenoid valve, that could be just like a valve controlling a radiator, opening and closing to let things through. And then you have a centralised controller for that, where you can tell the individual radiators to open or close. That's based on heat for it, whereas it will be based on, presumably, somebody operating the smart app to work with. But to give you an idea of the final sort of part coming out of that, at the bottom, this is the sort of thing to sort of create out of it, and this is actually the central heating system. This is the Evo Home one. There's other ones about, Netatmo and things like that. But the Evo Home one has got these radiator nodes connected to individual radiators, controlled by a centralised hub to it, and then you can connect to the outside world and to a smart device to sort of get there. And it's showing you what sort of type of communication is going at each level. What type of wireless communication it is, what type of message is going through, what type of power supply each one has. And that's what you're basically doing for this part 3. To give an overall systems diagram that shows not just how they're interconnected, where the individual nodes are, where the hub is, but what power supply they're using, what wireless communication they're using, what's on each hub. You might have, say, a Raspberry Pi on each hub to control it, or some sort of small processor, and eventually to hopefully try and cost one of these out. To look up the cost of things like a simple little motorised valve, and I give you a link to that particular one. It's only about £6 or so. And if you're going to make a node out of this, you'd need a processor. Bear in mind that the nodes you're making in the lab, they're nodes that are connected to your actual device, to your PC or to your laptop. And your motors or your sensors plug into that one, and your laptop, PC or whatever is doing that sort of controlling. That's not the sort of thing you can't have your laptop out in the lawn or something like that, controlling these sorts of things. You've got to shrink it down into some sort of small box, if you like. So we should be talking about something that's got the actual sensors and actuators together with a processor and wireless communications, how you're going to do that. So you're not to design any code in that. There's no coding work in that sort of part 3, purely just on a conceptual design that you think that this could fulfill this. And there'll be many such approaches to it. There's no one sort of solution. There'll be sort of many ideas to it, and you'll create this annotated block diagram similar to what's underneath with the appropriate information alongside it. There will be marks, the sort of top end for code quality, because a lot of this will be based on stuff that you can just almost copy and paste out of lab work. So I'll be looking at sort of how well your code's put together. You're in your final year of programming now. We're going to expect you not just to be able to code, but to code well. So some of the things that we're looking there in code quality, they're about, have you done a bit of refactoring? Have you taken out redundant code that's not needed? Is the code that you've got extensible? You can reuse it in different scenarios for it. So how well is that? How easy to read is that code and the like? Together with some sort of documentation just to show these things work. And I don't want to sort of concentrate too much on that at the moment. I'll go on to it later on. Today I want to talk mainly about these things at the start, the tasks 1 and 2. Now to that extent, there is this diagram that I want to work with. As I say, you can get hold of this diagram out of Moodle. Come on. But it shows you basically the overall conceptual system that you're going to be creating here. We're going to have some sort of servo control motor. So that's like the door, if you like. You don't need to actually attach a door onto your servo motor, just demonstrate that it's opening and closing for it. Well, the servo motor there represents the door opening, and a separate process at the top there for the RFID reader. Now, back in week 1, there is some code where both of those are in the same program. There's an RFID servo example. Now that sort of situation, where if you have them both in the same node, each one of those being a node, if they're both on the same one, then your RFID reader has got to be in the same physical location as your actual door. So it's rather like if I wanted to, say, undo the lock over there, then the processor that actually turned it would have to be the same processor that read my RFID card, if they're on the sort of same node. Now, we don't want that situation. You want it just so that you can sort of do this remotely and say, okay, well, I'll swipe it on the card reader here and the door opens to, let's say, let somebody in. It may be fairly close to it, may be a couple of yards off it, but these readers here, these are just readers. They don't actually actuate anything. They send their data off to somewhere else. So the card readers I'm talking about there that we've got recording attendance in the room. So somehow we've got to get some little bit of code here to read your data, to read your RFID to it, and then send a message over to the servo telling it to undo that. A couple of ways of doing it. The best way is through this MQTT broker in the middle, where if you use the publish-subscribe idea, the RFID reader can publish, if I'm not going to do validation just yet, but it could publish something saying open the door. So this could publish out to a topic. This could publish to, say, the topic called door with the value open. And this servo motor could subscribe to the door topic. And then based upon whether it said open or close the door. Or depending on how you want to implement it, if you say open, then the servo turns one way for say 15 seconds and then closes again. But basically you pass the message there using this MQTT protocol. So your RFID board being your broadcaster, and we did exactly that, again in one of the labs, that was one of the extension exercises, but you've got the code to do that from the slider. We've got a slider that publishes its current value. And we picked that up in the past. Well, last week writing it to a database. Every time the slider moved, we sent it to a database. But we're also sort of this week working on Android, picking up that slider value. So you'll find the code for the RFID publisher in one of these MQTT demos about publishing either the slider or publishing the RFID. And then in a similar way, the servo motor, which is a bit that's going to subscribe to that, will subscribe to whichever queue. Perhaps just calling it the door might not be enough. You might want to sort of fully identify that with your username and then /front door, /back door, depending, because you might have multiple doors that that thing's working on. So that's the way really to get that sort of initial part working, to get the RFID board talking to the servo, use MQTT. You could, if you're sort of a bit wary about using MQTT, you could have the card writing to the database. Again, that's one of the exercises that we did last week. We had the slider writing to the database, and one of the extension exercises was the RFID to write to the database. You could sort of write it direct to a servlet to work with, but the servo motor would then need to detect when you've actually done that update. You get your servlet perhaps keep asking the you could get your servo to keep asking that server, have you got a new value yet? And I often give this analogy of say, sort of taking a long drive in a car. You've got your two 5 and 6 year olds in the back, and they're constantly saying, are we there yet? Are we there yet? Are we there yet? Every sort of 5 seconds, and you get really annoyed as the driver saying, shut up, will you? And basically, these kids in the back are they're wanting to be told when they're actually there. And that's like the servo motor. It wants to be told when an RFID has actually produced a value. Now, people swiping the card, it's only going to be at the most every few minutes as people perhaps sort of go in and out, maybe only 3 or 4 times a day. But this servlet needs really to be told, this servo needs to be told almost immediately. And the way in just using the database approach is for the servo to keep asking the database, have you got a new value? Have you got a new value? And keep reading the latest value. So the servo there is like the kids in the back saying, are we there yet? Are we there yet? Are we there yet? And it's much better if the RFID can broadcast out to anybody who's interested, we're here. There's a valid card being presented. So rather than the kids in the back saying, are we there yet? You tell them to shut up and just say, I'll tell you when we're here. Don't say anything. And then when you get to your destination, the driver, which will be the RFID board, announces we're here. And anybody who's listening in the car picks up that message. So your kids, your servo motor can sort of pick that one up. So a publish subscribe is a much more efficient way of doing it. You can do it using the database, but I wouldn't recommend it. You'll get the code working, but it won't be very sort of good, efficient code. We will need a database. The publish-subscribe model doesn't keep all the old messages. So it doesn't store them away in the database. It's just a third-party broker that's managing that publish-subscribe idea. So in order to store these, you'd have to have either your RFID or your servo motor connecting to that servlet, connecting to the servlet which connects to the database, to say, can you just store this success, or can you store this request to get in there? Depends on what you're wanting to store as part of it. Now that sort of work about storing in the database is what we did in Lab 4. So that sort of thing is in Lab 4, this bit is here in Lab 4. The bit about the publish subscribe covered in Lab 3. The bit about the RFID working really was in Lab 1 on the servo to sort of work with it. So as I say, the code to use has been around there already for it. The other bit about connecting the Android part, I'll just mention in a moment. This is what we're doing here in Lab 5 this week to sort of connect to it. Now what it's going to mean is that you're going to have these things here. These are the separate nodes. You've got a node here, and this being another node for it. This being a servlet. Now hopefully you might sort of recognise that there's a sort of a bit of a difference between the ones on the left and the ones on the right. The ones on the left are the client ones, who are either broadcasting data or receiving it. They're putting in a request for some data and getting it back, or they're saying, here is some sort of data. This side over on the left is the client side. Whereas these things over here, the sort of server side, and it will entail you having at least 3 separate running processes. You'll have over here, over on the right hand side, you'll have the server running, and in terms of the type of project that you want there, that's in Eclipse, if you like, that's a dynamic web project. Whereas the clients are just your standard Java projects in Eclipse. Some people that I've sort of been talking to, they started creating, say, a dynamic web project and put the clients over here on the server. The physical equivalent of that, this server is a thing that might end up in the cloud somewhere. It might be things like you're talking to the Philips Hue server that's recording the status of your light, or the Evo Home radiator home control kit, again out there in the cloud. But the physical devices aren't actually connected to that server. That server is running on a separate server machine separately. And there's no, that machine doesn't have the motor connected to it. Your server's likely to be in some sort of remote location. These card readers aren't going to be connected directly to it, and your motor isn't going to be connected directly to it. So the server is this thing owned by the manufacturer, or whoever sort of sold you the system. Might be cloud-based, might be on their machine, their sort of home site, but the client side is the thing that's in your actual house. And you're not going to have the server in your house, because this server side, whilst we're talking here to, say, this might be your home, it's also going to be interacting with somebody else's home, say some third-party home. So that might be Bill's home, Sue's home over here, and somebody else's home, Annie's home. So we might have that server talking to multiple ones. And they physically wouldn't all be on the same one, because the server's recording the state of multiple users. That's why that table that you have had a user ID to identify whose data you were referring to. So when you come around to setting this up and doing your initial state, make sure you have a client project with at least 2 processes in it, 2 classes in it, one for the RFID board, one for the servo, and then a separate dynamic web project with your server team that will be writing out to the database. And then you'll submit, as I say, certainly at least 2 projects. One project with your client side, one project with your server side. That's why you've got 2 demos for the labs. You had a Fidget server and you had a Fidget Labs. The Fidget Labs was your left-hand side with all those bits that interacted with your actual devices. The right-hand side was your Fidget server classes with that sensor server DB, or the original sensor server, and things around that. So try to get those 2 things sorted out. And that was one of the mail messages that I, again, sort of tried to post out around the forum. I put out a message about the client and server needed. Basically saying that the assignment will need at least 2 projects. That server-side project and the client-side project. And then you'll also have an Android Studio one. I'll just bring that in a second. So one of the Eclipse projects will be the server-side one. That's where you've got that equivalent of Sensor Server DB put in it. That will receive sensor data from the clients and store them in a database. Whereas the other side will be a standard Java project. And that's the bit that's going to be interacting with these sensors to pick up the data or to activate the data. So they're not the same project. They're client and server, and they're typically physically in a real sort of situation far removed from each other. What this will allow us to do, if you do get them removed from each other, it means that the server side, it's up to the server code to decide where these things should be stored. So if these are your clients sending across the data, they won't need to know anything about how this service is actually storing that data. The client shouldn't know that you're storing it in, say, a MySQL database, or where that database is, the fact that it's on Mudfoot, or the fact that you're using these credentials, this username and ID password to get into it. All that is irrelevant to the client, and they shouldn't sort of know about it. The reason for that is if the person managing or the company managing that server side decided to change from a MySQL database to an Oracle database, or perhaps change the user credentials, or maybe change the structure of the table that thing's been stored in. If you did anything like that, changing usernames, changing location, the host name, if it was stored in the clients, all that information, you'd have to update all those clients. All those clients would have to have that sort of updated version with it. And potentially these client apps, there's thousands, hundreds of thousands of apps. And how many people update their app at the time it should be updated? You might get some message saying your software needs updating. Oh yeah, I'll do it later. I'll ignore it. And if you're not careful, you'll end up with your clients all running different versions of your sort of software. Some of which have got the old credentials, some of which have got the new credentials, and it's just going to be a mess, basically, to sort out. The way in which to do it is to keep that server constant in one location. So you just have it at evohome.com, philips.com, or something like that, and let the server side decide where to put the data, and the client just sends that data to the server. Now this is in relation as well to another good question that was put out about how does your Android code interact with these RFIDs, the servo and the database itself. It's the same sort of idea. This Android app that you're creating doesn't talk to the database direct. It talks to the servlet. So it's much the same as how the RFID or the server will talk to the server. They issue the same commands to talk to the server, but the Android app shouldn't know the details of what that actual database is, how you log on, what's its host name, username, password, and all that. That shouldn't be stored in your Android code. Just connecting to the server, you say, can you get me this RFID data, or can you get me the current lock status out of it to change? And if it wants to broadcast that, if it wants to communicate with, if your Android program wants to communicate with RFID or servo, again, this can just use MQTT. So it should have the ability inside your Android code to use this MQTT to either publish something or subscribe, so it should be able to do both. So for example, if I wanted to publish, I might have a button saying what to set the temperature to, and I can enter a temperature, and when I click the button, it can broadcast out that temperature. Or, let's have just a button that says close or open. And when they click on that, you publish something to the lock. so that when you click on the open button, you publish out a message and the servo motor is listening to that message topic. So long as the Android app knows which topic to publish to, and the servo motor is listening to it, then yeah, you can pick that data up. That was the exercise in this week's lab to implement the publish. The subscribe bit might be just to display, well, what's the current status of the door, what's the current status of my light, what's the status of, or can I change the status of a light, that sort of thing, what's the status of my heating. So you perhaps have some sort of display that every time somebody published, that display would do a subscribe. So you can subscribe to any one of these topics, and if you subscribe to the RFID board with that RFID meter code, whenever it publishes a message saying such a body has swiped their card, if you're subscribing to it, you can pick up that card number and just display it. And again, the thing that we did this week in the lab, or you will be doing this week in the lab, is for the Android code to subscribe to a slider or subscribe to a temperature. And every time somebody publishes a different temperature or publishes a slider, that thing gets picked up. So you'll find that the code that you work on in this week's lab will be very useful in that task 2, to be able to sort of put that together. It may also, again, if you sort of want, it may also communicate with the server, i.e. a server thinks, all right, but I mean, it won't communicate again with a sort of database, but it can sort of pass a message to the server saying, can you tell me the 10 most recent logins? That sort of thing. It depends on what that servlet is offering to you. Where's that coming from, you know? Sounds like somebody's rubbing against a microphone somewhere. No. Anyway. Whatever your servlet's offering, you can communicate with through the others. Currently, we've got a servlet that says, if you give me some sensor data, I'll store it. And it's also got this bit that you did last week saying, if you tell me the sensor data that you want, I'll give it back to you. So you can use some of that code from Lab 4 that we have. There's some Lab 4 code where the data was either being retrieved or stored in JSON string format as it's sort of coming through. I'll put I can see a few sort of people taking sort of shots of this. This will obviously be available in the video trip, but I'll take another photo of this at the end and just publish that up as being the final bit of scribble that sort of came out of it. So there's a variety of things to sort of get working. The basic one is just to get the MQTT part working between the RFID board and the servo. Later parts might come into how you might validate that RFID card. An initial version wouldn't do any validation. You just swipe the card and the door would open. A better version would at least do some sort of validation. Now again, we did that in the right in the first lab. You took an RFID card and based on the value you said hi there or go away or something. Like if it belonged to Billy No Mates, you told them to go away. If it belonged to anybody else, you said hi there or something similar. And then we had a list of values that were actually stored inside the RFID code, and you said, is it in this list? That would work for sort of fairly simple validation where you've got the list of valid cards stored in the RFID reader code, but it's not really realistic. The RFID reader wouldn't really have a list of valid IDs. That is more likely to be stored over on the server side. So you need another little server that perhaps the RFID board could say, could pass an RFID tag over and do that top one, the validation there. The RFID code, put in a request to a validator servlet, not the store this in the database one, but a validates one that perhaps just looked up that RFID value in a list of valid cards. So you could just have over on the servlet side, they may be held in memory. Ideally, you'd have a database table of valid parts to it. And ideally, again, you might validate for that particular user what the valid cards are.
Why don't you store it on the same server, and once it validates if it's valid or not, it will store in the main database on the same server, like so-and-so user try to access it, then sends a sort of...
Yeah, perfectly good. Yeah, that's a very good sort of idea about sort of storing it once you've sort of validated it. I mean, you're talking about a different servlet, if you like, and having sort of
be the same one.
Yeah, the sort of same one. I mean, yeah, you could have your actual bit that wrote it into the database doing a check and maintaining your list of valid ones. My own idea would probably be that you'd have a separate validator over here. Currently, the server that you've got here is this bit. I'm running out of space on here. You've got the bit on here that's called sensor server DB. And that's responsible for storing or retrieving values out of the database. What I would suggest maybe they have is a validator servlet, so that whenever somebody swipes that, it contacts the validator servlet and says, is this thing valid? And gets something coming back saying yes or no, and then this can then publish something saying open the door. There's many ways to solve these. I don't want to say, well, look, you've definitely got to do it this way. And yeah, what you're suggesting is another valid way of doing it. I'm expecting to have a variety of solutions coming out of it. Not necessarily, I don't expect the same block of code coming out of everything. You've got the same starter files, and we've got that conceptually how it's looking to it. It's going to be up to you to actually do that implementation. Sorry, I'm not starting this one now. Can you very quickly send a thing around? So I'm just sending the register out. So something like that will be your sort of model to work with, and there's an indication there of which bits of code to take that from, where you'll find the code to help you with the RFID client, where you'll find the code for the servo and the MQTT demos. And as I say, certainly after this week, you'll have enough. You don't need any more sort of formal lab practice sessions after this week to do that task 1 and 2. Even task 3, the bit about sort of doing the design, we've more or less sort of covered enough within the sort of theory side about the layout. You can just go back to how this thing's assessed, where the sort of marks are coming from for it. We've got this bit in the layout, in the original one, about what we're to do for it in task 1 and 2, that's the actual sort of code for it. But towards the end, you'll see like where the marks are coming from for this. You're going to submit just a single zip file of everything all together. But the very sort of starting off from the very basics, and these are going across tasks 1, 2, 3, and 4. Sorry, 1 and 2 at the start. Depending on these sort of zeros, if you like, just down at the bottom there, you've made no attempt. Well, hopefully we're not going to get anything from that. But the sort of basics there, I've given you in the labs enough to get in that 40 to 50 range, just by almost copy and pasting, yeah.
For part 3, like who are we designing for, what's the budget? Because I do something quite different for Harriet versus Steve from Salford.
I'm not quite hearing you, sorry, can you
For part 3, what's
Yeah.
the budget and who are we designing for?
Well, use your own sort of budget. I mean, eventually, because what you build, the question there was what's the budget for part 3 if you're sort of doing some sort of design. I'll leave it to you to come up with something that in your mind sort of seems reasonable, bearing in mind that you're probably likely to be wanting to sell these, not yourself, but eventually somebody can sell these as like a home product. Now, somebody isn't going to pay £5,000 for a single sprinkler in the system. They may pay about £50 for it, but in developing a prototype, just as an example, and I'll just follow up on that question and come back to the thing. Just as an example, that particular actuator, that's a little valve actuator, costs something like £6 or £7. Now, attached to that, you're likely to need something like some sort of processor controller. Now, a very expensive way of doing it would be to use a Raspberry Pi at 30 quid, which is a bit of overkill. Really. You can get one of the, if you have sort of Pi Minis, perhaps, to work with it, because it's only going to need a small amount of code. But, what we're talking about here is a conceptual model. When it comes round to, we're not in the product design, finishing sort of thing, where you actually going to manufacture this. If it came around to something like that, then yeah, the cost would shrink right down to it. But it's just to give some sort of idea that you know the components involved in it, to it. Such as a Raspberry Pi costing about 30 quid, say £8 to £10 for that. Possibly some sort of communications module, depending on what your processor can do. It might need a Zigbee controller to it. A lot of these things you need to sort of recognise, according to your design, what do I actually need on that processor? And it may well be that you come out with something that's going to cost, in your mind, £100, and then you put that recommendation out, and then somebody has to, let's cut that price down. It's never going to sell for that. But I'm not too bothered about what price you come out with, as long as it's a price, that the stuff that you're recommending does actually do the job for it, yeah. So just going back to that sort of costing out, yeah, there's the bits in that sort of 40 to 50 range that the program sends the data between the RFID thing and the motor, and the values aren't stored. That's just basically you get it working using MQTT. And the mobile development has got something to be able to display and activate the log. That's basically what you're doing in the lab this week. So if you've done the lab and more or less just use a lab code, then you're going to, that's your starting point. Like, I'm giving you the start point to work with. After that, the 50 to 60 range, you're making some attempt to store the data. So the RFID card will be broadcasting that sort of data out and hopefully storing it to it. Similarly, the actual mobile app does actually activate the server. Sorry, does actually activate the servo to work with it. Later on, you're then making sure that you're doing this JSON exchange, and you might be doing that right from the start. You might have to put some of this in at the start, but the data being swapped over should be in JSON. Similarly for the mobile sort of app. And then you're building in things like validation parts to it. The top part of it, the things in the 85 to 100 sort of range, really are dependent on code quality. Is that code that you've written easily amendable? Is it, has it been sort of refactored to get rid of all this sort of redundant code? Have you put any sort of new independent development in there? So there's some sort of functionality that takes it a bit beyond. We're looking for the 85 to 100 one is certainly the very distinctive range. You've got to show that your work is distinctive, not just you've done the job. Just doing the job will get you something between 50 and 65, 70 sort of thing, if you sort of actually do the task. To do them well is the thing that gets you the better marks coming out of it. Now I will devote in future weeks, most of the labs for the next few weeks will be around, sorry, I'm finding the right one, will be around like next week. I'm giving people time to finish the Android one, and to be able to sort of work on some of the previous ones. The week after we've got a tutor week, so there's no lectures and labs in that week, 5th of November. You'll just have meetings with your personal tutor. But after that, I'm starting to do in the lab just catch-up sessions, assignment help sessions to it. We'll get back on track with new stuff towards the end of November, when I'll have a lab on voice control using the Amazon Echo and things like that. But certainly the next 4 weeks or so devoted to lab catch-ups, assignment work, give you that chance to actually use the kit in the lab. By the way, I was asked yesterday about is there a solution to Lab 5 today. I'll publish the solution at the end of this week. Just bear with me a second, guys. The solutions for this week, I was one of my own bits of feedback. I was finding that in the labs, a lot of people are just sort of sitting there chatting between themselves, you know, sat in a little group before, gassing away, perhaps just taking the solution and running that, thinking they've understood it. I'm publishing the solutions towards the end of the week, so that in the labs you're actually having to do a bit of thinking. I was thinking it was getting a bit sort of too easy to be working today. Has the register sort of gone up to still on the inside? If you can bear with us 5 minutes to start the register, it's still just put the back of it and come down to the front to get signed.
Yeah. You have the register?
I'm just hoping somebody's going to bring you down. Can somebody bring the register down with them?
No, just put a little bit.
I've got like an interesting, important question.
Right.
Why does the mobile app need to connect to, like, why does it need to be aware of MQTT? Now, I know one of the main benefits is it can subscribe and doesn't constantly need to check the database, but if you add new devices or want to make it more secure, if the server connecting to the database is the only thing it's connecting to, you can ensure more security due to the fact you can...
Well, yeah, there are pros and cons. There are pros and cons to sort of doing it this way. Yeah, and if you connect to the database, you can say you've got the very latest one. However, the way in which you design your publish subscribe queues will be based on when you install it. When you install the app, say, locally on your machines, you'll identify what your current sort of positions are, what your current sensors, actuators and things are, what queues they are, and then start broadcasting out to those. And again, similarly on your app, you'll have an initial configuration for the ones that you're interested in.
But can't that set it up with the servlet database? Which...
Well, it could do, yeah. I mean, you could initially get those publish subscribe queues off the database and then use the MQTT. Or you could do, I mean, you could just forget MQTT altogether and go entirely through the database. But you've got this problem then of
but thinking
how does the individual actuator know when to turn on? Like say, how does a door know when to open?
Because the one with the database on will be connecting.
It doesn't know where they are. How does the database know where the door is?
You can set it up in the config.
You can in that, but then people move it around their house or they move it to a different house or something like that. Basically, you're talking about a problem. Yeah, it's been sort of fairly well discussed in any way, sort of thing. But one of the problems is like the things like it's like having, say, a server at your house that other people are trying to get to. And your IP address changes
more
all
like
the time.
The Amazon Echo. Like you've got the Alexa app. You set it up initially to connect to your home Wi-Fi, but then you can do everything through like the Alexa app, which can basically connect to Amazon, and it's aware of where it is.
How do you know Amazon's using the database and not something like MQTT?
I'm just saying, like, you don't necessarily have to be on the same network to connect to it.
Or
You can connect to Amazon.
Yeah, through Amazon, the Echo sort of does it like that. But when it's controlling your home devices, it doesn't necessarily communicate direct to your, like the Amazon Echo in most cases won't turn your lights on if it doesn't have an